Hello everyone, welcome to our YouTube channel. Today we are going to start with the first class, and this class will be about the math fundamentals, right? We will be discussing the basics of mathematics which are essential to clear the competitive exam, like banking, particularly the banking exams or the SSC exam that if you're talking about, right? First of all, I would like to tell you that these particular exams, particularly these one-day exams like bank exams or SSC exams, these exams require a lot of speed, right? Because you have to attempt somewhere around 100 questions in a time span of 1 hour, right? So in 60 minutes, in order to attempt these 100 questions, we'll be having 100 questions, and these 100 questions to be attempted in a time of 60 minutes, right? So it's a game of speed, that how fast we are able to calculate, how fast we are able to solve the question. That is more important, and particularly it becomes more important when we have a sectional cutoff, right? Particularly in bank exams, we are given the sectional times 20 minutes for the math section, right? So in order to solve these 35 question, 20 minutes of time, right? So it becomes very difficult unless and until we are good with the calculation, right? So first of all, today I assume that you are at zero level, right? Some of you might be having in the process of their studies, right? You might be preparing for these exams. Some of you might have prepared for the exam, but in this session, I would like to put some importance on those concepts, right? Those things which are very essential, very important if you're targeting the competitive exams, if you want to crack these exams, right? So first of all, I would like to talk about the basics, right? So in basics, what we say that rest of the things we'll be covering up in these sessions. But first and foremost important thing that you need to do is you need to be well versed with the tables, right? Tables from 1 to 20, right? Tables from 1 to 10, I think that everybody is aware of. Even table of 11, you people might be well versed with, right? But what I'm trying to focus at is we need to be very clear that the tables between 12 to 20, right? From 12 to 20, the tables. Now we need to have a direct, we should be able to directly produce a result, right? If I ask you 18 sevens are, you should be able to straightway go to the answer, that's 126, right? 19 sevens are is what, right? 18 six is what? 16 eights is what? 16 sevens is what? 14 eights is what? Directly we should be able to get one answer, right? So first thing that you need to stress upon is that is tables, right? And I have seen thousands of candidates cracking these exams, right? But when we talk to any candidate, what was their success mantra, particularly to crack the bank exam or the math section, particularly if we talk about. So the main focus is they were good in calculation and particularly the tables, because they not only help you in the quantitative section, right? When you go for the data interpretation section, particularly when we go for the exam of SBI, where the whole of the section in the mains exam you get only data interpretation. So in order to solve those data interpretation questions, we need to be very good with the tables, right? Because in mathematics there are two parts, right? I would say that in mathematics there are two parts. One is concept. One is concept. Concept means to say that one statement will be given, right? You come across one statement, and by reading that statement you make a decision that yes, this is the statement, this is the question, right? And what are the calculation you have to calculate, carry out afterwards, right? So first part is concept, where you make the understanding of the question, right? Once you have the understanding that what has to be done, multiplication, percentage, division, addition, subtraction, whatever the things that you know, that by reading, going through the concept, you are clear at what you have to do now. So second part is that is calculation, right? And this part, this calculation part, that consumes time, that needs time, right? This is where we have to put up some time, right? Because if you have to multiply, it needs time. You have to find percentage, it needs time, right? So what we will be doing it in the first few sessions, we'll be working upon the calculation part, right? Because this is basic and this is something that you need to work in the beginning, right? And once we are done with the calculation part, we'll move on to the concept part, and when we will be solving the conceptual questions, then we can apply those calculation concepts into the conceptual part. Fine. right? So a few of the basics, otherwise we'll go through the things, right? Go through the fundamentals where we will learn the shortcuts of solving this complex questions or complex calculations. But beside that, right, I need some of the things on your part, some of the things that you need to solve at your end, right? So first thing is that is tables. You need to be well versed with the tables from 1 to 20, right? Part 2, the second part is you need to be have clear idea about the squares, right? Squares from 1 to 40. From 1 to 40, squares should be on tips. So if I ask you what is the square of 27, you should straightway come out with the answer 729, right? If I ask you the square of 35, you should be able to find out that directly it is 1225, right? So what you want, it's in a fraction of seconds, you should be able to find out the answer to these things. Tables from 1 to 20, squares from 1 to 40, right? I'm telling you that if you follow these things, if you follow these concepts religiously, right from the heart, right, if you start following right from scratch, right, you will not, I can commit you one thing, you will not find any problem in the throughout your arithmetic, right? Whatever the things that if you want to crack the exam, just start following the things religiously, right? That is one thing I want to say. Third thing is that is cubes. That is cubes. Cubes you need to learn from 1 to 20, right? And normally in all the exams, like not particularly in the officer level exam, but in the curricular exam, we get one of the questions from the based upon the cubes, right? So we need to be well versed with the cubes, and particularly when we go for the questions, we get some questions based upon approximation, right? And when you go for the approximation, normally there is some role of cubes has to be there, right? So what I want that you learn these cubes, cram these cubes from 1 to 20, and so that when the question comes in front of us, we should be able to solve that question in seconds, right? And in seconds, I'm telling you that we'll be solving the question in a span of say 2, 3, 4 seconds only, right? So we'll come to that later, right? But these are the three things you start working on right from now, right? So next, what is the motive of today's session? Today, I'm telling you that today is the first class of fundamental, right? And this we have already we have the fundamental classes, but this class is purely will be purely in the English medium, right? So in today's session, we will be focusing upon multiplication part, right? Multiplication part, right? So various concepts of multiplication, various tricks of multiplication that we'll be learning in this session, right? And today I'm assuming that you know the tables. I'm assuming that from 1 to 20 you are well versed with the tables, right? And you should start working on this thing, right? Because in the sessions to come, right, I would ask you to solve the question, and if you're not comfortable with the tables, you will take a lot of time, right? You will not enjoy the sessions. So what I want, that these are very small things. I have asked you only three things, right? Only three things I'm asking you to do, right? One is tables, second is squares, and third one is cubes. Nothing else, right? Rest is leave rest of the things on me, right? Whatever I'm telling you, just follow those things, and you will find the mathematics is super easy, right? You don't need to worry about it. So let's move on. We move ahead with the multiplication part, right? The tricks of multiplication. How do we solve these questions, right? So first thing that I would tell you that the one very simple calculation I'm giving you, right? 24 into 35, right? I'm going to tell you one of the best concept and most used concept, right? The concept that will be that you people will also be using very frequently, right? And very simple one. It's not like Vedic mathematics or some typical one. It's very easy and can be applied everywhere, right? In the most of the questions, right? So the question is 24 and 35. That's how do we multiply? Normally we are used to multiplying these things, that we write one number at the top, other number below that, and then traditionally we multiply the numbers. But here, right? Otherwise, I know that here you can write 24, you can write 35, then you can multiply the things like way. 5 4s are 20, 5 2s are 10, 10 and 2, that's 120 is there. Then 3 4s are 12, and 3 2s are 6, 6 and 1, 7, right? You follow this one, 0 and 2 to 4 and 8, right? We get the answer to be 840, right? So this is what we used to do till now. But do we have the time to write this way and solve the question in this fashion, right? No, we have to solve, because this is not the question we are going to expect in the actual exam, right? This can be one of the so many calculation involved in one particular question, right? So what we do over here, similarly, just like this question, right, I'm going to ask you one to solve one more question. This is, question is 12 into 70, right? 12 into 70, this is the question you're going to solve, right? So now 12 into 70, what is 12 into 7? 12 into 7 is 84, and next we get 0. The question becomes very easy. So I can solve this question 12 into 70 in 1 second, right? Because I know the table. I've told you, right? I'm assuming today that you are well aware with the tables till 1 to 20. I'm assuming it, right? So let's follow it, right? But if we know the tables till 20, then how we can solve these questions, right? So 12 into 7, it is 84, and we get the number to be 840, right? Fine. So what we have done, this multiplication and this multiplication, both are the same multiplication. Only thing I have done is I have just halved this number and doubled this number, right? This is half of 24 and this is twice of 35, right? And we get the same answer. If I divide by 2 and multiply it by 2, net result is same, right? Net result, we are multiplying the number by 1, and that hardly changes the hardly makes any changes into the number, into the actual value, right? So answer is going to be same. Clear, right? Here I take one more example to make a better understanding, right? Say I'm going to multiply 28 into 45, right? Now here in this multiplication, I don't know the table of 28, and same, and I don't think that you might be knowing the table of 28 as well, right? I don't know the table of 45 as well, right? But when I'm going to multiply these two, right? Otherwise I have to write down, and then the question will become a little bit, it will take some time, some more time, right? So what I do, instead of this, I just half this number, this will be 14, and double of this will be 90. So 14 into 9 becomes 126. So my answer becomes 1260. Simple, right? In 2 seconds I get the answer, right? Simply I have to half one number and double the other one. And once I know that this 49 is 126, and I just need to apply the 0 and we get the answer, right? I take one more example. Say I have number is given to 36 into say 75. 36 into 70, I have 5, I have to calculate. So 36, I don't know the table of 36, I don't know the table of 75. What do we need to do? Simply half this number and double this number, that's 150. And now 18 into 150, right? So if I know the table of 15 or 18, I can apply it directly. I can find the answer is 0. 18 5 is 90, 9 balance, 18 1 is 18, and 9 is 27, right? This is one thing I can do. And otherwise, I can again apply, I can reapply the same concept. Half of this number is 9 and double of this is 150 is double, that become 300, and answer is 2700. I get the same answer over here, right? So it's a very simple concept. Simply what we need to take care is we need to half one number and double the other, and equations are going to become very easy for us, right? I take one more example. If I have to multiply 44 into see, it's 112.5. 112.5, 44 into 112.5, right? How do we multiply? I don't know the table of 45, I don't know the table of 112.5. Simply I half this number 22 and double this one, right? And if I double it, it is going to be 225. Double of this 112.5 will be 225. So it is 22 into 225, right? So next what we do, half of this, that is 11, and double of this will be 450, and we get the answer to be 0. And we'll come to that how do we multiply a number by 11, right? But straight away what I can do, 11 5s are 55, and 11 4s are 44. 44 and 5 is 49. 495 is the answer that we get, right? The question will become very easy, right? I take one more example. Say it's given to be 62.5 into 48, right? So here we're going to multiply these numbers, right? And I know that this is not going to be half, this has to be doubled, right? Don't fix yourself that the first number is to be doubled or the first number has to be half. No, right? We need to analyze the digits. That when the digits come in front of me, I will take a call at what I have to do, right? I don't want you to fix up your mind, not fix up your brain on anything, right? We are going to work with the digits, right? Actually, the digits are guiding us what we have to do in this particular calculation, right? So what we do, we double this number 62.5. If it is double, it will become 125, and half of this will be 24. We apply it again, it is 250 into 12, right? If we can apply 25 into 12, 300, I know that the question will become easy. Otherwise, what we do, we can apply it again, it's 500 into 6. The answer will come out to be 3000, right? So question are going to become very easy once we apply this concept, right? And this is one of the most common thing you can apply, most common concept you can apply while making the calculation, right? I'm going to take up a few of the more examples, right? Say question is 56 into 1.25, right? If this is the question, 56 into 31.25, right? How do we solve this question, right? Otherwise, calculation seems to be a little bit typical, right? But here, we just go ahead and half of 56 28, and double of this will be 62.5, right? Again, what we do, half of this is 14, and double of this will be 125, right? Again, half of this is 7 and double is 250. 225 into 7 is what? 175 and 0. 1750 is the answer that we get, right? So we can make the question very easy by using this method, right? Now, one thing might be going through your mind, right? This concept is particularly helpful when we have one number ending with the 5, right? And other number should be even, right? So this is not the case. Actually, we can generalize this concept to the other multiplication as well. Say I have one multiplication, say 37 into, say, I take it to be 32. Say 37 into 32, I have to multiply. Now, I don't know the table of 37, I don't know the table of 32, right? But here, as I told you, that what matters is the understanding of the digits. That's very important. Here, look, I cannot half this 37, right? So I will not do anything with the 37, right? I will not half this one. On the other hand, I know that if I half this number, it will become 16, and I know the table of 16. I know the table of 16. So I have this number and double this one. If I double this number, it will be 74. So now we have 16 fours are 64, 6 balance, 16 sevens are 112, 112 and 6 is 118. 1184 is the answer that we get. 16 fours are 64, 6 balance, 16 sevens are 112, 112 and 6 is 118, that's 1184. You understood that what is the benefit of knowing the tables? I know the tables, I can simply apply 16 fours and I get the answer, right? Similarly, if you have a question, say like you have to multiply 47 into, say, 34, right? So I don't know the table of 47, I don't know the table of 34 as well, but I know that if I half it, it will become 17 and double of this will be 94. So I'm not worried about 94 because I'm not going to read the table of 94, right? It's very simple. 17 fours are, it is 68. 6 balance, 79s are 153 and 6 is 159. So my answer is 1598. Very easy to find, right? Very easy to do it, right? So we're not fixed with anything, right? We're going to have fixed mindset that this is what we have to apply, but this is the most common approach that's going to help you, right? There will be a lot of questions where we'll be having some typical data, typical things, right? And we'll be able to solve this question very easily. One more example I would like you to solve, right? You write down, say the number is 72 into 18.75, right? This is number given to you. Now, I don't know the table of 72, I don't know the table of 18.75, what can it do, right? I know I can half it, half will be 36 and half of 36 will be 18. So I know the table of 18. So on the other hand, what I can do, I can double it, right? Half of this is 36 and double of this will be 36. 18 to the 36 and 0.75 doubled, it will be 1.5. So it will come out to be 37.5, right? If I half it further, it will be 18 and it will be 75. And I can do it further, 9 into 150. The 15 nines are 135 and 1350 is the answer. So we got it. We got it. We were able to make it very easy, right? So what we need to do, very simple concept. I'm telling you, this is half into 2. This is the concept that I'm telling you. That's simply half one number and double the other one, and things are going to become very easy for you, right? And this concept is, I'm telling you, this is the most important concept that if you're going to the calculation, right? There will be a lot of things. There will be a lot of things that if you go through YouTube and other videos, right, you can find a lot of shortcuts will be there, right? The teacher are telling you a lot of things to do, that you can do this, that, and all, right? But I'm telling you, this is the most important concept. This is the most important thing, most important application you can apply practically, right? Otherwise, there are a lot of things that which might impress you, right? But practically, this is the most important thing that will help you in your exams. I'm telling you, right? I'm grunting you, right? This is the most important thing. Just try to master it. When you apply this, when you solve these questions, just try to apply this concept in your normal approach. Fine, right? So afterwards, I hope that you are done with this concept, right? And now you apply this concept in the upcoming lectures or upcoming sessions. That when you solve these questions, just try to. I will also be applying these concepts regularly, but I want you people also to follow these concepts, right? So afterwards, next we move on to the next part, right? P, that is multiplication by 25. Multiplication by 25, right? How do we multiply a number by 25, right? So what do we do? It's the same concept we're going to follow, right? So what we have done earlier, right? Say we have a number, say 25 into 32. We are going to multiply these numbers, right? So one concept that one thing that I can do is I can get this number, right? I can multiply this number by using the table of 25 or using the table of other number, right? And other thing, what I can do is similarly add the concept that we applied in the last question, in the last concept, right? I can divide this number by 4. I can also multiply this number by 4, right? If I'm dividing one number, I have to multiply the other number as well, right? So what do we get, right? Here 4 into 25 is 100, and if I divide 32 by 4, I get 8. So my answer will be 800, right? What is the value that I get? I get the value to be 800, right? So I get the answer to be 800. Got it, right? So in the next question, if I have to multiply 25 into 44, right? So I multiply this by 4, this will give me 100. And divided by 4, this will give me 11. 11 into 100, so answer is 1100, right? So whenever I have to multiply a number by 25, what I need to do? I need to divide the number by 4. And by multiplying 25 by 4, I'm always going to get 100 only, right? Say if I have to multiply 25 into say 36, what I do? I divide it by 4, I get it 9, right? And if I multiply this number by 4 into 25, I'm going to get 100 only. So instead of doing this, I can skip this step, right? I can skip this step, right? I can directly divide this number by 4, I get 9, so I can write the answer to be 900. Say it is given 25 into say 24. So I simply, multiplying with 25 means divide the number by 4. It is 6, the answer is 600, very easy, right? 25 into 16, the answer is divided by 4, that's 4, the answer is 400, right? Say 25 into 48 divided by 4, it is 12, answer is 1200. 25 into 72 divided by 4, we get 18, the answer is 1800, right? So very simple, that what we are doing is that if I have to multiply a number by 25, I'm doing nothing. I'm just dividing the other number by 4, right? And applying 2 zeros at the end, right? So on the other hand, right, normally you might be thinking that all these numbers, all these examples that I have taken is, all these numbers are those numbers which are completely divisible by 4. But if I say if I get a number 25 into say, I assume into 33, right? I'm telling you, when I have to multiply a number by 25, what do we have to do? We have to divide the other number by 4. So we are going to divide 33 by 4. So 4 into 8 is 32, right? So what is left with? What is the remainder left here? Remainder left here is 1, right? So what I do, 25 into 1 is 25. So my answer is 825. Should I repeat? Yes, please. Yeah, let's go again. 25 into 33, I divide 33. As I told you that if I am multiplying a number by 25, simply divide the other number by 4. So 4 divides 33. 4 into 8 is 32. So if it goes till 32, we are left with one remainder. So remainder is 1. So 25, we multiply that 1 with 25. 25 into 1 is 25, right? So the answer is 825. Say, I take one more example. So it's 25 into, say, the number is 38, right? So what I do, I divide it by 4, and it comes out to be, say, 9. 9 4s are 36. Remainder is 2. So 25 2s are 25 into 2 is 50, right? Clear? Say, I have to multiply 25 into, say, it is given to be 47. I divide it by 4, 4 into 11, 44, remainder is 3. So 25 into 3, that is 75. 25 3s are 75, right? So whatever the remainder is left, right? In case it is completely divisible by 4, no problem, we apply the 2 zeros, right? In case there is some remainder, say remainder is 1. So in case of 1, we divided by 25. Remainder 1 means 25, remainder 2 means 50, remainder 3 means 75, and remainder 4 means, remainder 4 will never come, right? If we are dividing one number by 4, we will never be having a remainder as 4, right? We will be having a remainder of 0, 1, 2 and 3 only, right? We can have 0 remainder, 1 remainder, 2 remainder or 3 remainder, right? So if we have 0 remainder, it means it is completely dividing, and when it is completely dividing, we simply apply the 2 zeros. Right, I think it's very easy concept, right? Easily applicable. What we need to do is, right, I take a few more examples. Say 25 into, I'm multiplying 26, right? So divided by 4, it is 4 into 6, 24, remainder is 2. Remainder is 2 means, it will be 50, right? 25 into, say, it is 31, divided by 4, 4 into 7, 28, remainder is 3. 25 3s are 75, right? 25 into, say, 55, divided by 4, right? So 4 into 13, 52. I know, I told you that I'm assuming that you know the tables, right? If you're not knowing the tables, you might be having an idea that's what are the challenges, what are the limitations you're going to face, right? So 13 4s are 52, remainder is 3. So 25 3s are 75, right? 25 into, say, 75 is the number, right? So we divided by 4, 4 into 18, that is 72, 3 remainder, 25 3s are 75, right? 25 into 85, I have to multiply, divided by 4, 21 into 4, that's 84, we are left with one remainder, 25 into 1, the answer is 25. So this is how we solve the questions, right? This is how we solve the question when we are considering the question which are where we have to multiply a number by 25. Clear? Done, right? And along with this, that I'm going to discuss one more thing, right? Let's go to the next page, right? That is the divisibility by 25. Divisibility by 25, right? So how we divide a number by 25, right? So another important concept. Let's take one example, right? If we are going to divide 325 divided by 25, right? What do we get? What do we get in remainder, right? So here we go. I need to read the table of 25 till 32. 25 into 1, that is 25. Remainder is 7, and it becomes 75. 25 3s are 75. So my answer is 13, right? Clear? Now, what I'm telling you is apply the reverse concept, right? We have just done one concept in the previous video, right? In case that you feel that I'm going a little faster, you can pause the video, solve the questions after on, and then follow my solution, right? So here the question is 325 has to be divided by 25, right? So how do we approach it? How do we solve this question? One method I have told you, this is the traditional way, this is the normal way we used to do it earlier as well. But now here we go. That's how we apply our approach here. See, in the just previous case, what we used to do when we are multiplying a number by 25, what we were doing? We were dividing the number by 4. And then whatever the question was there, we were writing over there, and then afterwards, if remainder was 1, then we are writing 25, remainder was 2, then 50, remainder 3 means 75. We are using this one. Now let's do the reverse one. 325 has to be divided by 25. So earlier we were dividing it by 4. Now let's multiply it by 4. So last two digits, this 25 has to be separated. Then rest of the number, rest of the value, this 3 is left. 3 into 4, it is 12. And 25. Well, why 25 is here? 25 means it came from 1. If remainder was 1, then 25 was written over here. If there have been 50, then there would have been remainder would have been 2. If there have been 75, instead of 25 there was 75, then remainder would have been 3. So here it is 325. So 3 into 4 is 12, and 25 was written because of 1. So 12 plus 1, that is, my number comes out to be 13, right? I take one more example. Say it is 450 divided by 25, right? What do we do here? What do we apply here? How do we apply here? We multiply, we separate the last two digits, we multiply the rest remaining digits by 4. 4 into 4 is 16, and this 50 came from the 2, right? 16 plus 2, the answer is 18. Right? Let's discuss a few more examples that things will become easy for you. 575 upon 25, right? We separate the last two digits. 5 into 4, that is 20, and 75 was written, then 75 came from 3, right? So it is 23. This 75 corresponds to 3. This is from the previous concept. That's a multiplication by 25. I'm writing it from there because I'm writing 75, then it means it came from the remainder 3. So it is 20 plus 3, that is 23. The answer is 23. If I write a few more numbers, like if I write as to be 650 divided by 25, very easy. 6 into 4, 24, and 2, that is 26. If it is 875 divided by 25, 8 4s are 32, and 3, that is 35. I can directly write the number to be 35, right? If it is given to be 925 divided by 25, so it is 9 4s are 36, and 1, 37 is the answer. If it is like 1175 upon 25, directly I can write 11, this separate this one, 11 4s are 44, and 3, 47. If I have to write 1350 divided by 25, 13 4s are 52, and 2, 54, right? If I have to write say 1675 upon 25, so 16 4s are 64, and 3, 67, right? If I have 1825 upon 25, so it is 18 2s are, I can write this 18 4s are 74, 72 plus 1, 73 is the answer, right? If we have 2150 upon 25, it is 21 into 4, 84 plus 2, that is 86. I can straight away write the answer, right? No worries, right? Very simple concept, very simple approach, right? You can multiply it by 25, you can divide by 25, no problem with the things. The things are going to be very easy for you people, right? So till now we have done the 3 concepts. The first part was that was half and double, right? You multiply a number, you double a number, and you half the other part, and the calculation will become easier. In the second part, what we have done the multiplication by 25, and in third part, what we have done the divisibility by 25. How do we divide a number by 25, right? So in the next part, in the fourth part, what we are going to do is, right, I hope that things are clear till now. So what you can do, you can start following the things, right? What you can do, that you can take up some more examples, because ultimately, here in this video, what we are doing, we are just understanding the concepts, right? But these concepts are going to remain with you for a very short period of time, right? Unless and until you start utilizing these concepts in your routine question, in routine solutions, right? When you solve the question, you apply these concepts, right? And when you apply these concepts, these becomes you become familiar with these concepts, right? Otherwise, what may happen, that if you don't practice these concepts, what happens when you actually go for the question, right? You forget to apply these concepts, right? So we don't get used to applying these concepts in the practical questions. So what I want you to, you people need to do lot more practice, so that when you're solving some questions, when you're going through some question, when you're doing some calculation, so then you should be able to apply these concepts. You should be able to involve these concepts into this one, so that your calculation become easy, right? One thing is clear, that I think that everybody will agree that yes, these concepts are going to are going to help you out, right? Because these are the things that I have discussed, which are practically going to help you out in the questions, right? So next part, in the next part D, that we're going to go another important one, that's multiplication, multiply by 11, right? When you have to multiply a number by 11, very simple thing, very simple concept, right? Say it is 3754 into 11. This multiplication is given, right? You have to multiply 3754 into 11, right? So you can we know the table of 11, we can apply that as well, right? But otherwise, we're going to follow a very simple approach. In some cases, somewhere I have seen that some teacher teach you that you write the complete number, and then write the same number again below that, and then add up those values, right? Just skipping the last unit digit, right? Now what we do is we apply here is very simple thing, right? We simply write down this 4. We just simply write down this 4 here, right? We write down the unit digit here. Then 4 plus 5 is going to be, then we add up, then after writing the first digit, right, what we do, we add these numbers in pairs. 4 plus 5 is 9. Then 5 plus 7 is 12. 1 caret, 1 caret. 7 plus 3 is 10. 10 and 1 is 11. Right? 7, 5, 12, 1 caret, 7, 3, 10, 1, 11, again 1 caret, and 3 plus 1 is 4. So what I get is 41294. What I get is 41294. Right? Now, if we go back again, if we take another example, let's multiply this number 41294 again by 11 into 11, right? Again, this number has to multiply by 11. Let's see that's how it is applied. This 4 will remain as it is. We write the first digit, first unit place digit is as it is, that is 4. Then 4 and 9, we add up in the pair. 4 and 9, that is 13, right? 1 caret. 9 to 11 and 1, 12. 1 was caret, 9 and 2, 11, and 1 caret, that is 12. Then 1 caret, 2, 1, 3, 3 and 1 caret was 4. 2 and 1, 3. This 2 and this 1, this is 3. And one number, that one was carry over, so it is 3 plus 1, this is 4. Then 1 plus 4, that is 5. And then this 4 will, because no caret, 4 will come as it is here. Right? Let's multiply it again. We multiply it by 11. Here's 4, we write here. 4 and 3, we write it to be 7. 3, 2, we get it to be 5. 2, 4, we get it to be 6. 4 and 5, we get it to be 9. And 5 and 4, we get it to be 9 again. And this 4 will come as it is, right? But when we are done with the pairs, right? There's 4, then 4 3, then 3 2, then 2 4, then 4 5, then 5 4, and then we don't have any other number. So we in last step we bring this 4. If there's no carry forward, we write the 4 as it is, right? And let's do this one more time, right? It's 11 into this. This 4 will come as it is, 4. 4 and 7, that is 11, 1 carried. 7 5 12, 12 and 1, that is 13, right? 5 6 11 and 1, 5 6 11 and 1 was carried, that is 12. Now we are left with one more, right? 9 6 15 and 1, that is 16, right? Again 1 carried. 9 and 18 and 1, that is 19. Again 1 carried. 9 4 13 and 1, 14, 1 carried. 4 and 1, 5. So we get the answer to be 54962 314, right? This is after multiplying this number by 11, right? Very easy thing, right? Like I'm taking one more example. It is 62397 into 11. If the number is given, right? So what we do, we write it 6 7 6 13 9 7 16 and 1 17. 1 carrot 9 3 12 and 1 13, 1 carrot 3 2 5 and 1 6, 6 and 2 8 and 6. This is the answer that I get, right? Very simple. Clear? You can multiply it again by 11, again by 11. You can successively again by 11, again by 11. You can multiply these by 11 successively and then find out the answers, right? So this is something that we can apply very frequently. Whenever we get some question, we have to apply by, multiply a number by 11. Simply start from the unit digit and then keep on adding the numbers in pairs, right? We add up the numbers in the pairs, and towards the last digit, right, that is left a single digit, and then if something is carried over, we add up, otherwise we simply write down that number, right? So I think that multiplication by 11 is easy, and you can follow a few more examples, right? You can solve at your own. You can solve a few more examples at your own, right? Fine, right? Okay, next I go to the next one, that is next multiplication, that is multiply by triple one, right? How do we multiply a number by triple one, right? Look here in this question, if I take a one example, it is just an extrapolation of multiplication by 11, just extending that the same concept. If it is given that 3 4 6 3 4 6 5 into triple one, right? If I have to multiply this number, so what we do in 11, there was two digits, two ones, 1 and 1, right? So in that case, what we're doing, we were writing the one digit, unit digit, then we were adding up the pairs, right, until the last digit is left alone. So here we have three ones, so we cannot add up in the pairs only. We start same way in the unit digits, like this. We write 5, then we added 5 and 6, that is 11. We write it here, that's 1 is left. Now here we have 1 1 1, this so 3 times 1, so we have to add in the triplets, right? So first is written as 5, then 5 and 6, that's 11. Now we add up all these three. In the next step, in the third step, we add up all these three. 5 6 11 and 4 15, and 1 was carried, right? 15 and 1 16. So we are left with 1 now. So in the next step, in this step we have added these three. In the next step, what is done? This 5 is left over, and we add up the next three, right? We add up these three numbers. 6 4 10, 10 and 3 13, and 1 was carried over. 13 and 1 14, right? 1 was carried over, and again here it is 14, 1 is again carried over. Now we don't have anything else. 3 4 and 6 is done. Now 4 and 3, now we again come back. 4 and 3 7, and 1 was carried over. 7 and 1 8, and finally we write the 3 as it is. 3 8 4 6 1 5. In the one step we can write on the calculation, right? I think that we can take one more example, right? Just try to follow this thing. 4 6 2 7 into triple one, right? So what do we do? In the first step, we write 7 as it is, 7 into 9 as it is, right? Then After the first pair, the single digit first, then one pair, this is 279, and then afterwards the things change, that we now need to take up three digits, 7 to 9, 9 and 6, that is 15, right? Now 1 is carried, 2, 6, 8, 8 and 4, 12, and 12 and 1, 1 is carried as 12 and 1 is 13, right? Now we're left with 1, 6, 4, 10 and 1 is, that is 11, 1 is carried, 4 and 1, that is 5. My answer comes out to 513597, right? I hope the question is easy for you people. You can take a one more examples, 3 4 more examples, you can try it out, so that whenever things come in front of you, you should not think like that, yes we have done but we are not able to recall that, right? So that's why I'm asking that you practice a few more examples like this, right? So my purpose over this video is to introduce you people towards these concepts, so that you can apply these concepts while solving the questions, right? Okay, so multiplication by 11 or multiplication by, especially this particular multiplication by 11 will be quite frequently you will be using it, but when we go for the multiply by 11, so in this case you will not be using this multiplication very frequently, right? But otherwise, that if you people have been solving these questions, solving the previous year papers, or the you have been appearing in the competitive exams, right? Then where this concept is used, right? I'm just going to discuss with you, right? Just going to solve one simple question with you people, right? This is one of the very frequently asked question. 6 into double 6 into triple 6, right? 6 into double 6 into triple 6. This is one of the very frequently asked question, right? So I want you people to solve this question. Please solve it, right? I give you a time of say uh, 30 seconds, right? 30 seconds I give you. Just try to solve. Just solve this question. Yes, please, everyone. Everybody, go and solve this question, please. Go ahead. Yes, please. Do it fast. Yes, everybody. Do it fast. Time is up, right? Okay. See, I hope that you have got the right answer. Yes, yes. Let's go ahead, right? What that's when we teach the students, right? What is the normal problem do you get, right? So some of you might have got it right, and that's okay, right? But otherwise, when we have this question in front of us, right? What the most of the students, 90% of students, what they do, they take 6 common, then 1 into 11 into triple 1, and then they solve this question, right? Which is totally wrong, right? Because see what's happening, it's being multiplied, right? It's a multiplication. So we can, if had it been this plus sign, then we could have taken it something common, right? It's basically, if you look at the things, this 6 into 1, this 6 into 11, this is 6 into triple, right? So there's 6 in every digit, right? Every number, every value, every term, we have one 6, right? And when we are multiplying it, this is 6 into 6 into 6, right? So we cannot take one 6 common, right? And I'm telling you one thing, that I was very surprised. One of the students, right? Even conceptually, if we see that he was wrong, but otherwise it was very difficult to answer his point, right? What he said, that we have 6 into double 6 into triple 6, right? What he did, right? He took 6 common, right? He took 6 common, and then he says that I have taken one 6 common, and now I'm left with 1 here into. Here we have two sixes, one six is common, so he said that one six is taken out, one six is left inside, right? And then here he said that three sixes are there, one six is taken out, and now he is left with two sixes, right? Or if Out of 3 6s, 1 6 is taken out. We must be left with the 2 6s only, right? So this is not the way the math works. Both these things are wrong, right? Very simple thing is that this actually the number is this, right? And whenever we get this question, what we do, we find 6 into 6 into 6, right? We take out 6 from each of term and multiply this. So it is basically 6 cube into 11 into triple one, right? So the question in front of me is 6 cube is, I told you to learn this cubes till 20, right? So again, we are going to use that concept as well. 6 cube is 216 into triple one into 11, right? Here, now I have an option. I can multiply it by 11. I can multiply it by triple one as well, right? So I'm doing it by triple one. I'm multiplying it by triple one, not by 11, right? If I multiply it by triple one, what will happen, right? Because I know that out of these two, the multiplication by triple one is a little bit complicated. Not that much, but in comparison to 11, this will be a little bit difficult. So I do the difficult work early, right? So I don't want that to keep the difficult calculation towards the end. I will do it first, right? So what I can do, right? I know that how do we multiply it? It's 216 into triple one. It is 6. 617, 617 and 2, that's 9, and 213 and that's 2. 23976 into 11, right? And this we know what we'll get. That is 6, 7, 6, 13. We are left with 1, 9, 7, 16 and 1. 17, 1 balance, 9, 3, 12 and 1. 13, 1 carry, 3, 2, 5 and 1, 6 and 2. It's 2, 6, 3, 7, 3, 6. This is the answer we get, right? So next time that when we get some question that's if it is given that 8 into 88 into 888, this is the question that we are going to solve this question, right? So what we do in this question, we simply apply 8 cube is 512 into 111 into 11, right? So when we multiply it by 111, it is 2, 213, 3 and 5, that is 8, 516 and 5 into 11, right? This is going to be 2, 2 and 3. I write it straight with this. It is 2, 2 and 3, that is 5. Then 3 and 8, that is 11. 8, 6, 14 and 1, 15, right? 6, 5, 11 and 1, 12, right? And 5, 1, 6. 6, 2, 5, 1, 5, 2. Actually, we get the answer, right? So what we have done, 8 cube is 5 and 2 into 111 into 11. We multiply 5 and 2 by 111. Since 2 is written here, 2, 1, 3 is written here, 2, 1, 3 and 5, 8. Then 5 and 6 and then 5, right? Now, we multiply it by 11. This 2 is written here, 3, 2, 5, 8, 3, 11. 1 is written here, 8, 6, 14, 1, 15, 1 caret, 5, 6, 11, 1, 12, 1 caret, 5 and 1, 6, right? So 6, 2, 5 and 5 to the answer that we get. So we can easily find the answer to these ones, right? If 5 into, if I get a question that's 7 into 7 into 777, I can find it easily. If it is given 9 into 9 into 999, I can find it easily. That's a very simple question, right? But this is the approach we need to follow. Otherwise, I'm not saying that you can solve the question, right? You will be able to solve the question, but what's important is that how much time we take to solve the question, right? That's important, because we are not having the abundance of time, right? We are fighting against time only, right? It's a game of time only. I'm telling you one thing, that if we are talking about the competitive exams, right? It's basically when particularly we talk about the mathematics. Suppose you appear in the bank exam, right? And whether you get selected or not, that will be decided. Particularly if we talk about the mathematics section, right? Your performance in those 20 minutes math section in mathematics, your performance in those 20 minutes will decide that will you be shortlisted or not. Clear, right? So it means what you will be doing in your entire life, will be decided by those 20 minutes of your life, right? So what we are going to do is we are trying to maximize our performance in those 20 minutes, right? So we are practicing here, we are learning the shortcuts, we are learning the techniques right now, so that in those 20 minutes we can do our best, right? We can do our best, right? So we need to practice for that only, clear, right? So don't think that yes, sometimes the thought come across that yes, we can do it, right? It will save hardly say 5 seconds, say 10 seconds, say 15 seconds, right? But if we say 10 seconds from say 20 questions, right? So 10 seconds for 20 questions makes 200 seconds, right? And in those 200 seconds, if I can attempt say 5 more questions, if I can attempt 5 more questions, 5 more questions, 5 more marks, and I'm telling you that by how much marks, the students I have seen that missing out on the cutoff, right? 0.25 marks, right? A lot of students, everything is done, right? But they leave out, right? They're not being able to clear the sectional cutoff, something overall cutoff by 0.25 marks, 0.5 marks, 1 mark, right? So I'm giving you 5 more marks. So we need to do a little bit extra, right? See, the lot of students, right, who will be performing at the average level, right? But if we have to crack the exam, we need to do a bit extra compared to the average, a bit different compared to what the average students are doing, right? So that's why these things are important for we people to learn, so that we can apply these things in the questions, and we can save some time, and we can optimize our performance for the exams. Fine, right? Okay, let's move on to the next slide, right? Let's move on to the next thing, right? Next concept. It's very simple. This very simple concept. We are going to multiply this 100 plus into 100 plus, right? See, I'm telling you, this method is 100 plus into 100 plus method. This method is something that we very rarely apply. We very rarely we use it, right? But something when we go for the say clerk level exams, there we can find some calculation to of that's all, right? But it's something that we feel that students should not feel like this was not taught, or this was not taught in the class, right? But practically, this concept has very less utility, right? So let's move to this concept. Let's say I have to multiply a number 104 and another number say 107. I have to multiply these numbers, right? So now through normal multiplication I can solve it, right? I can write 101, 104 here, and then 107 here, and then multiply these numbers, and I can get the answer. No problem with that, right? But now through Vedic mathematics we can make the things easier, right? What we take, we assume the base. We assume the base to be 100, right? Now we compare these numbers 104 or 107. We compare these numbers with 100, right? So it is 104 is as compared to 100, it is plus 4. It is 4 more than this. 107 is plus 7. It is 7 more than 107, right? So in nutshell, what we get, here we have plus 4, here we have plus 7. In nutshell, how much we have? We have 4 and 7, that's 11 more than 100. So I simply add 11 to 100. So it will becomes 111. And 4 into 7 is, because multiplication is there, 4 into 7 is 28. We straight away get the answer. 111 and then 28, right? Say, if we get 106 into 111, if I have to multiply this, so it is plus 6. In this case as well, like the base is 100, it is plus 6, it is plus 11. So 6 and 11 comes out to be 17. So I get the answer to be 117, and 11 6 are 66. Directly I can get the answer. Directly we can write the answer. If the number is 107 into 112, what we do? It is plus 7, it is plus 12. 12 and 7, 119, and 12 7s are 84. Directly we write the answer. Very easy thing. Pretty easy, right? But we know that what we are doing, we have to compare it by 100, and whatever extra is left it out, we have to multiply this. 7 into 12 is 84. Directly we write, and we get the answer, right? Now, if we get some number like a bigger number, bigger value, like we have 108 into 115, right? So in this case, how do we apply it? It is plus 8, it is plus 15, and 8 plus 15 comes out to be 15 plus 8 comes out to be 23. So 100 plus 23 is 123, and 15 into 8, when we multiply, it is 120. So here comes the difference. Here, when we multiply 4 into 7, it was simply 28. Only 2 digits were there. Here it was 66, only 2 digits were there. Here it was 84, only 2 digits were there. There was no issue, right? But here what we get 3 digits. So it's apart from 20, we also get 100 place digit, that is 1. Here 3 is also at 100 place. Here we have seen this 9 was at 100 place, 7 was at 100 place, this 1 was at 100 place. Similarly, 123 we write 3 is at the 100 place. This one is also at the 100 place. So what we do, we simply, right, we put this one, we add this 1 into 3. So answer becomes 12420. My answer becomes 12420, right? I take one more example. Say it is given to be 109 into 116, right? So what we do, it is plus 9, it is plus 16, and 16 plus 9, that's 125, right? And 16 nines are 144. So this one here, this one has to be added into this 5. So my answer becomes 12644. If we get 2 digits after multiplication, it's okay, right? But if we get more than 2 digits, if we get 100 place as well, so that digit has to be added in the other digits as well, right? Next we go to, say, if I take up some another example, 112 into 118 is given, right? It's plus 12, it's plus 18. 18 and 12 is 30, that is 130. Our 18 to 12 is 216. So this 2 will get into this one. So we get 13216. Right? So I think it's pretty easy to apply. Right? So hardly an issue. Right? I can take one more example. If it is given the 124 into 115, what we do, plus 24 plus 15. 15 24 is 139. Right? And 24 into 15 will be what? It is basically when we have to multiply, it's half this one and double this. Right? Half of 24 is 12, and double of 15 is 30. So 12 into 30 is 360. Right? So here this 3 will get into 9. So it's 139 plus 3 is 142 and 60. So my answer becomes 14260. So this is how we can apply this. But this particular method is applicable only in case we have the numbers like 100 plus and 100 plus, right? One number is 100 plus, other number is also 100 plus. Only in that case we can apply it, right? On the same concept, we have same pattern. We have another concept that we call it to be 100 minus into 100 minus, right? If we have smaller numbers, right? Like we have 96 into 93. This we have to multiply. So if we go to this question, it is as compared to, again in this case also we take the base, and base we take it to be 100 only. We take the base to be 100. So it is minus 4, and here it is given to be minus 7. So minus 4. 4 and 7 is 11. So 11 less than 100 is 89. We decrease 11 from 100, that's 89. And 7 into 4 is 28. Straight, because both are negative. Minus minus is plus, minus and minus is plus, so plus 28. So answer is 8928. Right? Let's go to another example. Say it is 96 into 91. So it is minus 4, minus 9, 9, 4, 13, that is 13 less than, it's minus 13. So 13 less than 100, that is 87. And 9 4s are 36. Right? If we have, say, 88 into 92, so it is minus 12, it's minus 8. 12 and 8, 20 is decreased, so it is 100 minus 20 is 80, and 12 8s are 96. Straight away we get the answer. Right? In case we have smaller number, say it is given to be 97 into 98, it is minus 3 or it is minus 2, and 3 into is 5, so it comes up to be 95. 5 less than 100, that's 95, and 3 into 2 is 6. So we don't write it 6, we write it 06. because these last two digits are coming from the multiplication, right? I'm writing these two digits from multiplication. So these two digits will depend upon the multiplication. 3 into 2, that's 6, that is single digit. So instead of this writing anything here, so we'll write 0 over here and the answer will be 9506. And just like the previous example, if we have some bigger numbers, right? Bigger number mean to say smaller numbers, right? 84 into say 92 is written. It is minus 16, it is minus 8, and 16 and 8 is 24. So it is minus 24, 100 minus 24, we get 76 here, and 16 into 8 is 128. Right? So what we do, this one has to be added because there are 3 digits after multiplication. So this one will go into 6. So it is 7728. This will be the answer. Right? If we have some question like say 81 into say 88 is given. So minus 19 minus 12. 19 and 12 is 31. So 31 less than 100 will come out to be 69. And now 19 into 12 is what? 19 into 10 is 190. 19 to the 38. So 190 and 30 is 228. So it will come out to be 228. So this 2 will get into this, right? This will become 69 plus 2 is 7128, right? This is how we get these numbers. Okay, so again I'm telling you once more that these concepts is 100 plus or 100 minus, these concepts are very less used, but yes, somewhere during our calculation, during simplification, you might come across such things, right? I'm telling you these things just for the sake of this. Yes, you people might be knowing that these things do exist, these things can be done simply, right? But they're very less probability that we'll be we'll be applying this one, right? This will be helpful particularly when we go for the questions of simple interest or successive chains or compound interest, right? Then I will tell you that how to apply these things, right? There I will repeat these things again, right? And along with this, we can take up one more question, one more concept. Next concept is one number is 100 plus and another number is 100 minus, right? You might be thinking that I've taken the simple things only. Right? This is a little bit difficult, right? Not much, but if we apply the simple mathematics concepts, the question is very easy, right? Look here. If we have here 107 into, on the other hand, we have say 91. So here we have plus 7, base is 100, plus 7, here we have minus 9. In nutshell, what we have, this is plus 7 minus 9, so we have minus 2. So 100 minus 2 is 98. Got it? We simply add up these two, plus 7 and minus 9, right? So net we get minus 2. So 100 minus 2 is 98, right here. 9 sevens are 63. So now this is plus, this is minus, so it will be minus 63. So what we do here, we write 0, 0, 98, 0, 0, because 9 to 7 is negative. Had it been positive, we would have written straight away here 63, but it is negative. So 98 minus 63, it will come to 9737. This is the answer we get. 9737, right? See, it's given that 112 into 93. So it is plus 12 and it is minus 7. So 12 minus 7 is 5, so plus 5, so it becomes 10500, and 12 sevens are 84, minus 84. We get the answer to be 10416. 10416. This is the answer we get, right? So this is how we apply the 100 plus and 100 minus example, right? So this is a very simple one, very easy thing to pick, right? Very easily we can apply these concepts into our normal routine questions, right? Especially the concept that we have done in the beginning, that these are going to be very helpful when you go for these exams, right? Particularly the competitive exams, right? So this is the basic about the multiplication, right? I will take up a few more examples with regard to your multiplication concept, right? And in the upcoming lecture, that is basically duplex and triplex methods that we will take up along with the squares, the concept of squares, right? In that concept, we will take up the concept of duplex and triplex method as well, right? So till then, goodbye, right? I hope you enjoyed the session, right? Bye bye. Fine. Thank you.